Hey guys, so this is just going to be a quick video on confidence intervals. You may have seen it in research articles where they mention 95% confidence or 90%, 99, any of those CIs. There's several ways that it could have presented itself in videos, articles, not videos, sorry. Basically, what we're going to be looking at is how to calculate CIs, and what they are is basically how confident we are that our values lie between a range rather than just the mean. We've already gone over mean before, so the average of our sample. Variability, we've only discussed standard deviation, but there are other measures of variation, including the standard error of the mean, so the error rate of your mean. To calculate that, it is your standard deviation divided by the square root of your number of participants. We'll get into that on the Excel document. All of this can be done in Excel. There are a number of different confidence intervals or confidence interval formulas that you can use. I'm going to show you the one that we're going to use as it has to do with 95% confidence. Let me share my screen with you. Okay, right now here is just data on estimated VO2 max, just random numbers. Over here, you can see the formula for calculating CIs, but we'll get to that in a second. So average is just equals average. Highlight your data. Right, standard deviation equals standard deviation, SDV. Standard error of the mean, like I mentioned, is equal to standard deviation. Since we've already calculated that, I'll just click on that cell, divided by parentheses square root. There is a function for it, so SQRT. Double click that. Since it's looking for the square root of the number of participants, in this data set I have 10, so I will just type in 10. Okay. So our standard error of the mean is 2.66. There are generally upper and lower limits to your 95% interval, so this is where you get the range. The formula is mean plus or minus 1.96, since we're using 95%. That's the value we're going to be using, times standard error of the mean. Luckily, we've already calculated all this, so it equals the mean. Since this is the upper limit, it's going to be positive, so plus, in parentheses, 1.96 times our standard error of the mean, and we get 39. For the lower limit, we're going to be doing the same thing, only minus, since that's what plus minus is, equals mean minus 1.96 times our standard error of the mean. Okay, so what this is saying is we are 95% confident that our values lie between 28.58 and 39, rather than just thinking that it has to be closer to 33.79. So if I pull, let's say, let me pull every 2, hope this works, and check the average of that, and that average is likely to lie between those two numbers. It doesn't necessarily have to, since we're only 95% confident, but let's go ahead and get 5.3, 35.75, 42.24, 29.72, and 37.99. So just gonna write average here equals average if I type. $33.85 was my number for this. So yeah, it did lie between the upper and lower limits. I think that's all that I need to say for you guys. All we're doing with the 95% CI is trying to generalize or infer to the population based on our number of participants, the mean, and how much our values vary from the mean. hopefully this video helped. Let me know if you have any questions.